Just so you know, I'm recording now, so it's on video what delinquency are. I can't read through the colours. Right? No, delinquency are all on tape. You're being recorded. It's, yeah. Okay. So, last night's homework. Thank you.
Excuse me, please. Could Miss Head's geography class go to room 30 now, please?
Right. So I gave you one to draw and one to answer, wasn't it? So was it? I can't remember. 4 and 5. Right. I'm in the wrong exercise, am I? 4 and 5. 4 and 5. No. Am I in the right book?
It's page 405.
Oh yeah, it was histograms, yeah. Right, okay. Yeah, draw one and answer questions on one. Was there any problem? In any of them? Does anyone need me to do any bit of number 4 or any bit of number 5? No? Happy days. Right, so then we went on to the shapes of distributions, and then just comparing that, talking about standard deviation compared to the shape. Okay, will we just talk through all of these because they're nice and short? Right, it says, what is this distribution commonly known as? It's symmetrical. Give one real life example of symmetrical. Sorry? Height, yeah. People's height, people's weight, right? People's IQ. Most things are symmetrical, as in very few are super intelligent, super high IQ, very few have super low IQ, and we're all in here. Most of us are in here in the middle. Sorry.
I said people in the shop across the day.
People in the shop across the day?
You know when you go in and you can kind of shop on Google and it's like busiest hours?
Yeah.
It's like,
It depends on the type of shop though.
yeah.
Yeah. So, and it depends on the day, right? I wouldn't be a fan of that example, right? In this distribution, positively or is it positively or negatively skewed, please? Positively skewed. Ignore the two at the start, right? Everything's approximately, right? Okay. You will notice that most of the values are at the lower end of the distribution. So most of the values are over here, right? Okay. Give one real life situation, that example of this distribution, right? Okay. Where the value is low, right? The age at what people learn to cycle. Okay. Most people learn to cycle at a young age, don't they? Right? And some people don't learn to cycle until an older age. Right? Okay, I think that's the one in the book. Can you think of anything else? Number of children, yeah. Okay, most people have low enough, right? Okay, and then very few people have 27 children or whatever it is. Okay, is that right? Okay. Here are 3 distributions. Which of the distributions is symmetrical? A, B, or C? Geniuses. Which distribution is positively skewed? A. Which distribution is negatively skewed? Which distribution is most likely to represent this data? The weights of international rugby players. Ooh. International rugby players. I'd say, would they be?
They'd be heavier. Most of them would be heavier.
I would think symmetrical, would it? Would it be kind of an equal number of... Yeah, I'd have to think about that now, and I'm a big rugby fan, but I don't know. I'd say symmetrical, is it? Did you say symmetrical?
Yeah.
Yeah, I think symmetrical. I think there's, you know, there's a really big guy, and there's really small guys on the wing, and there's really big guys in the front row. And if you don't know rugby, you see how you're supposed to answer that question. So I'd say small guys in the wing, big guys in the front row, and everyone else is somewhere in the middle, right? That's what I think. Right. which distribution is best represents the IQ of a large number of second level students? That's definitely what? C, definitely C. We could argue over the rugby players, but we can't argue over that. Right, describe the and just nearly every survey is symmetrical. Nearly every survey, there's you know the way we're looking for examples up here, like you're clutching for examples for positively skewed and negatively skewed. Most of them are symmetrical. Okay, just bear that in mind. The distribution, describe the distribution illustrated below. What would you say? Negatively skewed, you would say? Yeah? Right, okay. For the mode, mean and median of this distribution, which of the three is the smallest? So they're in alphabetical order. So put them in alphabetical order, mean, median, mode. Right, okay. So mean, median, mode, that's them in alphabetical order. It's easy to see where the mode is. Where is the mode? The mode is the biggest here, isn't it? So the mode is here. That means the median is next here and the mean is next. They're in alphabetical order. So the mean will be down here somewhere. The median is here and the mode is here. Is that right? Okay. You can't see. Sorry. So mode, median, mean somewhere. Right? Is that okay? Right. Which of the three is the smallest mean? Which is the largest mode? Right? All okay with that? Right. Okay. So, you know, when you're figuring those out, the mode is all like up here, right, for this one. And they're in alphabetical order, either forwards or backwards. So it's mean, median, mode, right? Mean, median, mode, or mode, median, mean, right? Okay, they're always in alphabetical order, either forwards or backwards. It's easy to find the mode. It's here, right? Okay, so that means the median is there and the mean is there, right? Okay, does that make sense? Right, symmetrical, they're all exactly in the middle, right? Okay. Next one, consider the distributions A and B. Explain why the standard deviation of B is greater than the standard deviation of A. Right, first off we need to find out where the mean is. Where's the mean in A? It's between what? Sorry. Right, where's the mean of A? It's between what? 2 and 3, isn't it? Because it's symmetrical. So it's between 2 and 3. And most of the values are in around 2 or 3, right? So this would have big or small standard deviation? Small, right? Most things are huddled around the mean. The mean's in the middle. It's a symmetrical distribution, right? Here, right, okay, the mean would be... the mean is 2.4, thank God they tell me because I wasn't able to figure it out. So the mean is 2.4, so the mean is here, right, okay. There's big numbers there, there's 6 there, right, okay. But these ones are pretty far away, aren't they? So which one has the bigger standard deviation?
What do you mean by far away though? As in greater?
Far away as in a bigger number.
Okay.
Right, okay, as in there's lots of numbers that are between 4 and 5 here, right? Whereas there's very few numbers that are between 4 and 5 here,
Yeah.
right? So there's more numbers further away from the mean,
Okay.
right? Okay, as in there's 3 numbers between 4 and 5, there's only 1 number between 4 and 5, so there's 3 numbers far away from the mean, there's only 1 number far away from the mean there, right? So which one has the bigger standard deviation? B, right? Most numbers are further away from the mean there. Can you see that? Is that right? Will I ramble on some more about that, or are you okay? Okay, we'll take that as a
Can you ramble on?
ramble on. Thanks for saying it, Louise, because right, okay, so the mean is here, right, okay, so the mean is here, right, now, right, so there's 6 numbers nearly bang on the mean, isn't there, right, there's 3 numbers and 3 numbers, another 6 numbers right next door to the mean, right, okay, and there's, 2 numbers really kind of, well, the furthest away from the mean. Agreed? Right? Here the mean is 2.4. Okay? So there's only 3 numbers bang on the mean, right? There's 6 and 1, there's 7 numbers next door to the mean, and look, there's 3 and 1, there's 4 kind of the furthest away you can get from the mean, yeah? Okay, so there's more numbers far away from the mean, right, in B, right? Okay, remember standard deviation is spread out. How spread out is the data, right? Which one has the biggest difference between the lowest and the highest, right? Okay, and this one here, because there's more numbers huddled around the mean here. There's more numbers on the mean. There's more numbers 1 step from the mean. There's less numbers 2 steps from the mean. Whereas here, there's 3 numbers on the mean. There's 7 numbers 1 step from the mean, as opposed to 6 numbers over here 1 step from the mean. And here there is 3 and there's 4 numbers 2 steps from the mean. Do you know what I mean? From 2 blocks away from the mean, right? Whereas here there's only 2 numbers that are 2 blocks away from the mean. So that means there's less numbers away from the mean, right? Okay. Whereas here they're more spread out. So the more spread out, the greater the standard deviation. Does that make sense? Better sense? Right. Okay. Right. For each of the following pairs of distributions, state whether A or B has a larger standard deviation. If they are the same, state so. Right. The mean is 2.6. So, right. Here, right, and here the mean is 3.5, which is here, right? So, there's ones bang on, they're in the column with the mean. Here, there's nothing in the column with the mean. So every number is one column away from the mean, at least, isn't it? Right? Whereas here, it's either bang on or there's only 3, 1 column away. So A or B, which one is more spread out? B, right? Okay. A, right. Standard deviation is, the mean is 3, bang in the middle, right? Okay. Of a uniform distribution. The mean is 3, right? Okay. It's equal numbers either side, right? So everything, like it's equal numbers either side. Whereas here, the mean is also 3. And what about either side? There's equal numbers either side as well, isn't there? Right, okay, so I would say the same. Right, equally spread out. Because, you know, we have 6 numbers, 6 numbers, say, 2 blocks away from the mean. And here we have 6 numbers, 2 blocks away from the mean. So it's the same, right? This one just has more numbers in it.
What do you mean 6 numbers?
As in, see here, this column goes up to 3 and this column goes up to 3.
Okay.
So the mean is in the middle at 3. So there's only 6 numbers in this list and they're that much away from the mean. Here, there's 3, 6, 9, 12, 15, 18 numbers in this list. Right, okay? But the ones in the middle kind of cancel each other out. There's still 6 numbers, right, 2 blocks away from the mean. So it's the same.
You know in the one above that?
Sorry?
You know in the question above that?
Oh,
That one, there's 4 numbers away from the mean in each of them. As in like 3 to 4 goes up to 3 and 4 to 5 goes up to 1.
3 to 4. Yeah, but 3 to 4 is nearer the mean than 4 to 5. They're not equally
Okay.
far away from the mean.
Yeah.
Whereas these ones here, like all the ones in the middle cancel each other out, there's still 6 numbers equally away from the mean. You know, it's at 5 to 6 and 0 to 1. Right? Okay, this one. Right. Mean is 2.5, so it's in here. Right, okay. And here the mean is 2.5, which is in here. Right. Which one has more numbers away from the mean? A. Right, okay. A has way more numbers away from the mean, doesn't it?
Is that like essentially what it's asking?
Yeah. Oh, standard deviation, how spread out are they, how far away are they from the middle? Right, okay, right. Here, this one, 0.75, okay, so look, there's a lot bang on the mean, and everything else is 1 block away from the mean. Right, this one, 4.75, bang on the mean, and everything else is one block on the mean. What you say about the standard deviations here? You can't see. Right, what you say, so here, 0.75, bang on 6 numbers, bang on the mean. 4.75, 6 numbers, bang on the mean. And this has 3 numbers away from the mean, 1 block away from the mean. And the other one has 3 numbers, 1 block away from the mean. Tell me, standard deviation? Same, right, same. Are you getting it? Right, okay, let's look at this one. So, mean is 3.2, so it's in here, this block, okay. And this one, so 3.2, so we're looking at 6, right? And if you just look at one block, 5 and 4 are 1 block away, so there's 9 1 block away from the mean, right? Okay, we'll just look at that and see first. Okay, so 6 on the mean, here 3.5, yeah, well, there's only 4 on the mean, and then 1 block away from the mean there's a 5 and a 3, that's 8. What do you think? Which one is more spread out? B, yeah, right, okay, it has more numbers away from the mean, okay, the bigger blocks are away from the mean, right, okay, mean is 3, right, okay, mean is 2.9, okay, so you have to kind of see which numbers, which numbers are far away from the mean. So we'll say the mean is 3, so we've kind of 2 blocks bang on, so that's 6 bang on. This one 2.9, 6 bang on, that's not really telling us much, right? Okay, then 2 blocks away we have 6, 2 blocks away, so we have, sorry, 1 block away I should go, we have 6 there. 1 block away I have 3 and 5, 8, so I think that's more huddled around the mean, isn't it? Would you agree? So B is more huddled around the mean, so it would have the smaller standard deviation. Would you agree? Would you agree with me?
Yeah.
That there's more numbers huddled around the mean, right? Okay, there's more. Okay, so you're looking at which one has the most numbers huddled around the mean, and which one has the most numbers spread out from the mean. Okay, so girls, we're going to use this symbol now, right? See this, it's a Greek symbol, mu it's called, it's a U with a tail at the start of it, right? Oh, sorry. Right, see this mu? It's called mu, it's a Greek letter, that means mean, right? Okay, we're going to be using that in formulas now in a while, right? Okay, so instead of saying mean now, I'm going to say mu, right? Okay, mu, right? It just means U with a tail at the front, right? 2.2, well, what are you saying? 2.2 is there, right? 2.5 is here. Which one is more spread out? A, I agree, right? I'm moving faster, right? Mu is 1.9, just there, right? Okay, mu is 2.5 in there. Which one is more spread out? B, right? Okay, and finally, the shapes of the histograms are 4 sets of data shown below. Complete the table indicating whether the statement is correct or incorrect with respect to each data set. The data is skewed to the left, right? Skewed to the left, it's getting smaller as you head towards the left. Negatively skewed, okay? So which one is negatively skewed, would you say? C? I'd say C only, would you? Right, skewed to the right, A. The mean is equal to the median. That's anything that's symmetrical. B and D. B and D. D is symmetrical as well. Right? The mean is greater than the median. Wait now till I see. I have to think about this. Right? The mode. So we say mode, median, mean. So that means the mean is less. Right? Okay. So that means this one, isn't it? Mode, median, mean. So the median is greater than the median. I'd say A. Is that right? Positively skewed. Is that right? A, did you say that? Yeah. And the mean is, sorry, the mean is equal to, oh, we did that, and we did that. There is a single mode. There is a single mode. A, B, C, that's it. A, B, C. They all have one tallest block. This one has two, so there's no single mode.
Wait,
Right.
can you go back up for a second?
Yeah,
You know the A and B, like this second.
this one,
Yeah, like I don't understand that.
right.
Like how B is more spread out.
See, A, the mean is 1.9. So, right, okay, so there's 6 numbers exactly on the mean, say,
Yeah.
right, okay. There's 4 numbers 1 step away. There's one number 2 steps away, and there's 3 numbers 2 steps away. 3 steps away, right, okay. And then 2.5, if you should look at them. There's lots of numbers, there's 6 numbers here, there's 12 numbers 2 steps away. They're really far away. See these ones?
Yeah.
They're far away from the mean's in the middle. Whereas on the outside here, there's a lower amount of numbers. There's 1 number and 3 numbers.
Yeah.
Whereas far away here, there's 6 numbers and 6 numbers. Is that alright?
Yeah.
So there's more numbers on the outskirts,
Yeah.
right? So that means the data is more spread out. Okay? Right, are we good? Right, right, did you bring book 4 or did you just bring book 5? You brought both? Will we, I'm thinking we should probably do, no, look, we don't need to do those core exercises, do we? There wasn't a lot in there. Right, okay, I think we'll start statistics 2, so, right, statistics 2 is a bit of a different kettle of fish. It's a little bit harder, a lot more formulas and stuff. It starts off okay though. Yeah. Yeah, don't forget to come back. Yeah. Yeah. Not like 10 of them in a row, but 1. Right, girls, off we go. Are we all back? Statistics 2, right, and there's statistics 3, and we'll be doing a test at the end of all 3 statistic chapters, just in case you're wondering where's the end of chapter test. It'll be all 3 statistic chapters together, right, okay? Inferential statistics, right? Inferential statistics is where Yeah, it doesn't matter. We're going to talk about scatter diagrams today, right? Okay, right. Scatter diagrams. You know the way we had our graphs up to now have been age versus frequency, height versus frequency, weight versus frequency. It's always been against frequency. We've only been plotting univariate data, as in we've only asked our survey one question. We've asked people their IQ, we've asked people their height, we've asked people their age, okay? Now we're going to ask people two sets of data, right? Bivariate data. So now I'm going to ask you what you got in, what age you are, and what height you are, okay? Or I'm going to ask you two questions. I'm going to ask you what you got in your maths test, what you got in your English test, right? Okay, I'm going to ask you two pieces, to give me two pieces of information, so there is no frequency anymore. It's just two pieces of information, one person, two pieces of information, there's no frequency anymore. Okay, right? For a scatter diagram, you plot one versus the other. So I would take Louise's maths result, and she got 75, and then her English result, she got 89, and I go across 75 up 89 and put a little dot for Louise. And then I do Joan, and she got 27 in her maths, and she got 15 in her English. So I go across 27 and up to 15. That never happens, so that's why I said Joan. Right, okay, right, so each dot represents one person, okay? So sometimes you can use dots. I think in the book they use X's or whatever, it doesn't matter. It really doesn't matter whether you use a dot or an X, right? After plotting, we look for a pattern, okay? To see, is there a correlation, right? To see, does one influence the other, right? Okay, and sometimes you'll find it does, because it might be the sales of washing machines and the sales of dryers, right? Okay, there might be a connection, a correlation, there might not be, right? Okay, we say that the variables are correlated if there is a linear pattern. Right, we're looking for a linear pattern, as in we're looking for a line going up, or we're looking for a line coming down, okay? So we're looking for a line, right, that's what we're looking for. That's what we're checking out, okay? Right, okay, I'm going to get you to draw a scattered graph, right, because they're really annoying to draw, right, okay? So I'm going to get you to go to page 286, and I'm going to get you to draw a scatter graph there for Brian statistics and mathematics, right? So you draw a graph, okay? You unless they tell you differently, you put the top line of the table on the x-axis and the bottom line of the table on the y-axis, unless they tell you differently. Okay, sometimes they tell you differently, but that's kind of the norm, that you put whatever's at the top across the bottom. So across the bottom you'll be counting up to 93, so I'd go up to 100 up in tens, right? Okay, up the y-axis, the highest number you have to go up to is 89, so I'd count up in tens again. Here. What did I say it was number what? It's the 4, right, okay, just draw the graph for me, and it will okay, scatter graph are really easy to draw, and they often come up. I think there was one this year, right, okay, they often come up, right, okay, and they're lovely, as in you'll get 10 marks to draw a scatter graph like that a child in primary school could draw, right? So we like scatter graphs, okay, can I confirm that? We like them. So they're not in order, like you'll be drawing a point over here, and then you'll be drawing a point over here, and then you draw a point here, point here. They're not in order by any means, okay? So you go across to, what's the first first point there? Statistics, sorry. Sorry. So you, in the first one, you'll be going across 78 and up to 70 and drawing an X, right? Okay, and then you go across and you go up. So you'll be, it's not like before where you drew the first point and then the points followed on. It's a scatter graph. They're all over the shop, right? They're everywhere. So.
Mathematics percent is on the x-axis.
Say that again.
Is mathematics percent on the x-axis?
What's the first line of the table?
Statistics.
That's on the x-axis.
Okay.
So the first line of the table is on the x-axis unless they tell you differently.
Yes, if we do it the other way around.
It will be fine if you do it the other way around. I think you'll get the opposite answers to what we'll talk about. Leave it for the moment, okay? Yeah, okay, leave it for the moment. As in, did you do mathematics on the, so you're going across, where is it? You went across 17 up to 78
Yeah.
for your first point.
Yeah.
Right, okay. Yeah, would it be different? Yeah, you'll get a different graph. Yeah, I think we have to put the top row of the graph of the table on the x-axis, unless they tell us differently. right? Okay, so so of the table, the top row goes across the x-axis unless they tell us differently, and I don't think they will tell you differently. So if you twist it towards me.
I'm sorry, sorry. And for the TVI computers, do you remember what the name of the software is?
It's have you and I have a. It's not.
I
They're
can
not.
do the typing with them too, if
They're
they
not
need to.
signed up
I was
for it
talking to
yet.
Suzanne and
Yeah,
she was-
it's not
she did
signed
them,
up
okay.
yet. What I have is a PowerPoint. Wait, now let's see what am I trying to do here.
Okay.
I'll send you a PowerPoint, and it's Microsoft Office. Sorry,
I can do them off that typing.com.
yes, typing. That's what I did in mine yesterday. I did it yesterday. So I showed him this PowerPoint.
Do we have to work that other
No,
software? Or?
Needs is going to
Okay,
be signing us up,
okay.
and it gives you the email address
Okay,
and
perfect.
stuff right now. Sorry, I need to be in Outlook. Don't ask me to sign in now.
Technology, no longer.
Email. Oh, come on. Your hat, aren't you?
Yeah. I know, I didn't realise that that was what that meant. I was like, I thought I was.
He's the man for that. Yeah, right, okay.
Perfect, sure. And that's kind of showing what to do then.
Yeah, can I, we
Yeah.
just, browse this computer. Yeah, if you just give me a sec, cause, I might just open it up and show you, cause there's not much in it.
Okay.
Why isn't it? That's fine.
At the end, it looks like.
See, I knew this would happen.
Yeah, that's pretty much it.
What's that called? I'm really sorry. Are your class waiting for you?
Not the way back is now, I can just get them to that typing DNA and do this another day.
Yeah, yeah, I know I sent it to Alison, but it could be a year ago. So Alison, there we go, computer skills. Now in this, I've been updated, I don't know where I put it. Right, okay, I'll forward this
Yeah, the second one.
Right, okay, and I'm just going to open it for a minute just to show you one thing. It says, that's the website, right, okay. It's, oh no, it says 9, it's okay, yeah, it says 9, it's okay. Blah, blah, crap. They need headphones, they have devices, so they can work on their devices, so they can use their Bluetooth headphones. But if they want to work on the desktop in the computer, they need the headphones that can work, right, okay, and this is what a course when you log in, this is like when you log into Excel, there's a bit of theory and then you do an assessment and then you do a theory and an assessment, okay? And then that's a picture of what they get at the end. And that's the end of that. Yeah, so I will send it. Yeah, and it makes it look like you know what you're talking about. So.
Alright, that's perfect, thank you.
And then titanlens.com. Because it's not set up. Alright, okay. Right, girls, sorry about that. Right, have we, oh, I don't know why I closed that. Yeah, I shouldn't have closed that. Do you see all that? Was it all up there, yeah? There wasn't anything interesting there, but can I see your scatter diagram there, Diane? You're going to demonstrate. No, the one you drew. Right, does your scatter diagram look like this?
We can't see.
What is wrong with you? Right. What's it say? A bad workman blames his tools. So you're my tools and I blame you. Right, okay. Right, I'll have to zoom in. Right, does it look like this? Right, okay. Right, now the next question in that is it correlated? Right, okay. That means, is there some sort of a relationship between them? So I'm going back to the notes, right, okay, before we answer that, I'm going to go back to the notes and I'm going to show you what they mean by correlation, and we're going to put words on it first and we put numbers on it then, right, okay, so from current slide, so if we have a positive correlation, right, okay, it's basically almost a line going up, right, okay, you know, if you joined all those points, they're nearly a line going up, right, okay, right, so positive correlation is a line going up, right, okay, strong, so we can have strong positive or weak positive, so they're both lines going up, but one is closer to a straight line than the other. So if it's very near a straight line, we call it a strong positive correlation. If it's not so much, if it's, you can make a line out of it, but it's a weak line, a weak positive correlation, okay? Is that alright? So, strong positive correlation, weak positive correlation. Are we good? Right, you don't need to write this down because it's just scribbles really on the thing. Right, negative correlation, right, straight line coming down. Right, and what you think the next slide is going to say? Strong negative correlation and weak negative correlation. So there's a weak one right, the first one, right, yeah, it's a straight line, but there's not very good straight line, okay, whereas the other one is a good straight line, okay, right, very close to a straight line, right, and look at no correlation at all, right, not in a million years could you make a straight line out of those, so no correlation at all, is that alright? Okay, so look at yours and tell me what you have. You did number 5. Describe the correlation shown. Strong positive? Yeah, okay. And describe the relationship between the percentages achieved in statistics and mathematics for those students. Right, okay, put words on it. Okay, so you're saying it's a strong positive correlation, so they want you to talk about it in terms of statistics and maths. And basically what it means is, if the students did well in statistics, they did well in maths. Okay? That's what the strong positive correlation means. Right? When students did well in statistics, they also did well in maths. Okay? That's what the last sentence of that means.
So what if it was weak? Then would it
If it was weak, you...
That is kind of like it's kind of weak in the diagram, like in mine, it kind of is.
Is it weak? I'd say strong. I'd say strong. No, weak is, you know, you're stretching it to make a straight line.
Yeah.
Right, okay? So I'd say strong, right, okay? Now, causal relationship, you might want to jot this one down, right? So correlation, right, means one affects the other, as in, yeah, there was a connection. They correlated, as in, you did well at maths, you did well at statistics, right? But does one cause the other? Okay? Sometimes correlation could have a causal relationship, as in one did cause the other, but sometimes it's just completely random. Okay? Right? For example, statistics and maths is probably a causal relationship, because if you're good at statistics, it's a part of maths. So if you're good at maths, you're good at statistics. Right? So that's probably a causal relationship. Right? But if you did English versus maths, and there was a correlation, right? Does one cause the other? Just because you're good at English, does that mean you're good at maths? No, no. So it wouldn't be a causal relationship. So a causal relationship is, does one cause the other? So they can be correlated, as in they can both go up together or they can both come down together, right? But does one cause the other is a causal relationship, okay? Right? So correlation does not necessarily mean there's a causal relationship. Just be aware of that, because it could be the sales of computers and the sales of cars, right? And they might be correlated because, I don't know, loads of people won the lotto or something, right? But they didn't cause, just because you bought a car doesn't mean you're going to go out and buy a computer. Okay, what time is it? 12:01. I'm going to stop for 10 minutes and leave you do some questions on this, right? Okay, just before I move on again. Okay, so if we go to page 286, 285. Right, and we'll just do a few short ones. 1, 2, I won't make you draw anymore. 6, 1, 2, 6, and 7. Right, will you just do them now? it should take you less than 10 minutes, and when that's done, we can move on to the next bit. Okay? So 1, 2, 6 and 7 on page 285. Yeah. A ruler might be handy too in this, you know, when you're trying to figure out the correlation. Do you know, like if you use a ruler to see, you know, like are most of the dots, are they near the straight line, are they far away from the straight line, you know, etc. Have you number 1 done? Yeah. So which ones are positive correlation? C and E. Which one is negative correlations? A and F. Right. No correlation. B and D. Right. And strong negative correlation. A. Right. And describe the correlation in graph F. Weak negative. Yeah. Okay. Right. I'll leave you on to number 2.
Miss,
Yes.
you know if they ask for the weakest correlation,
The weakest correlation. Yeah.
could you say the graph with no correlation, or no, because that doesn't have it?
Yeah. No. Yeah.
Okay.
Yeah. That's the answer. D. I'd say there's weak positive correlation with D. Well, as opposed to no correlation. Would you say?
I see it.
Sorry?
Yeah, the things are going up, but like
It's very weak, but they are going up, aren't they? Kind of. So, yeah, you really don't have to use D in any answer except the last one, but I'd nearly say D has a very weak positive correlation. Have you done 2?
Yeah.
Which graph shows the strongest positive? Which one? B? Yeah. Which of the graphs shows negative correlation? C. And which shows the weakest? D. You're geniuses, right? 6 and 7, so are next. Boys' height and their shoe sizes. Men's weight in the timetable completed across. Ages of cars and their selling price.
No, I don't know where.
Right, have we 6 done? Yeah. Boys' heights and their shoe size. So as boys get taller, their shoe sizes tend to get bigger. So which one did you say? B? Yeah, yeah. I wouldn't say it's very close, but it would be, yeah, pretty. Right. Men's weight and the time taken by them to complete a crossword puzzle. C. No correlation at all. Right. Ages of cars and their selling prices. So the older the car, the lower the selling price. Would you agree? So which one is that? A. Right. And marks achieved in maths paper 1 and maths paper 2. Most people, if they do good on paper 1, they do good on paper 2. So D? D? Yeah? Okay. Now that's most people, right? There's always an exception to the rules, so that's called an outlier. Okay? Right, and I actually do number 7 then as well. Have you done? Okay, number 7, quickly. And we'll move on. Will we? 12:09, we will.
Oh, sorry.
Right, number 7. So, describe the correlation shown. What did you call it? Strong negative? Strong negative? Weak negative? What did you call it? Strong negative. Yeah, I think I'm with you on the strong negative. Yeah, yeah. I'm using my ruler. Right. I go strong negative. Is there a causal relationship between the variables? So age and price of motorcycle. Is there a correlation between the age of the motorcycle, I presume, as opposed to the person who owns it? Right, okay. The age of the motorcycle and the price of the motorcycle. Is there a cause? The older the motorcycle, the less it's worth. Yeah, I think there is a causal relationship there. Would you agree? Right, okay. We all happy? Right. Okay, we're mathematicians, we don't like words. So now we're going to put numbers on strong positive, weak negative, all that. Right, so we're going to put numbers on it, okay? Because we don't like words. So words like strong positive and weak positive, they're for English teachers, right? We like numbers. So if it's a perfect line going up, a perfect straight line going up, we said it's got a correlation coefficient of 1, plus 1. If it's positive, it's perfect going up, it's plus 1. If it's perfect line coming down, what do you think it's got a correlation coefficient of? Minus 1. If there is no correlation at all, the correlation coefficient is 0. Right. So correlation coefficients go between minus 1 and 1. Right. No correlation is 0. So the closer it is to 0,